Pretty good.
Okay. So composite functions 10.3. Composite functions and inverses of functions. A composite function means made up of. Okay, so composed of. Let's just do a brief. We'll do a brief review of just what a function would be. So if you have f of x is equal to x squared minus 5, okay, there's your function notation. And I say, hey, what's f of 3? Then wherever you see an x, you would just plug in the 3. So 3 squared equals 5. So f of 3 is equal to 4, and that would be the answer. Now, this, as you recall, just for review, that would be a coordinate point on a graph, 3, 4, right? So that's basic function notation. Now, a composite function means composed of. Okay, so a composite function, if you have, let's do these. If you have f of x equals 3x, okay, so f of x is equal to 3x, and then you have g of x is equal to x plus 1. Now you have a second one, and then you have h of x equals x squared plus 2. I mean, well, let's go, well, yeah, plus 2. Plus 1, plus 2. So here you have 3 functions given to you. These are not composite functions yet, they're just individualized. So f is a function, g is a function, h is a function. So 3 separate functions. A composite function would look like this. And let's go with f of, let's say, h of 2. Okay. Now, when they want you to find f of h of 2, sometimes there's confusion, like on a test or something. So I type this problem. Here's your 3 functions. Find f of h of 2, and people are confused. Well, where's the g part of this function? Well, the g doesn't have to be included. It just was part of if there was a g, on another example, which we will do. So just if there's no g part here, but there is up there, that's okay. You don't use it. It's just not there. Okay. So when you look at, and then like in the problems that you have to do, they'll give you 3 functions, let's say, or 4 or 5 functions, but then they only want you to utilize 2 of them to mess with. Okay. So in this case, we're going to be looking at the f function and the h function. Composite functions, you always work inside to out. So start on the inside and then work your way out. When I say that, that means is I have h of 2. So just like we understood, like f of 3, you plug in and you simplify and you got out 4. We're not going to worry about the f right now. We're only going to worry about what h of 2 is. So you want to find out what is h of 2. Don't worry about the f part right now. So we say, okay, h of 2, maybe I'll just do that right over here. H of 2, remember, wherever you see an x, you're just plugging in the 2. That's how functions work. And so you end up with h of 2 is equal to 6. So now, wherever you see an h of 2, it's like substitution, right? So h of 2 is equal to 6. So wherever you see an h of 2, what are you going to plug back in? Not h of 2, but what number do you get to plug back in? 6. So instead of asking what is f of h of 2, you're now going to say what is f of 6, because it's the same thing. These, for some reason, maybe it's more in like Algebra 1, they create a lot of confusion. Hopefully for us, they won't. It's basically just like a substitution problem. So I found h of 2 is 6, then I plug in. Now that I have f of 6, you're back to asking a question, something like this, except we have the f function here. You're not worried about the h part anymore. We've already dealt with h of 2. So when I look at f of 6, I'm only looking at the f function. So what is f of 6 equal to? Well, f of 6 is just equal to the 3 times 6, which is equal to 18. And that's your final answer. So f of h of 2 is 18, because f of h of 2 is the same thing as f of 6. So we get out 18. Let's do a second one here, but let's do it with this. Okay, g of f of x. This one usually becomes a little bit more challenging, because when we look at g of f of x, the thing that's missing, if you will, is it's missing a numerical value. We don't have a g of f of 7 or something like that. We have g of f of x. So this can create a little bit of a challenge for people. But we're going to try to work through it the same way, except now we can't plug in like f of, like we did with h of 2 and get out a value. We just have g of f of x. So what we're going to do is we're going to say g of, well, what is f of x? Well, we go back up here. What is f of x? 3x. So g of f of x is really the same thing as asking g of 3x, because that's what f of x is. F of x is 3x, so we would just plug in 3x. Now, you remember the F of chicken video we watched? You can even plug in poultry, right? You can even plug in poultry. So the whole point of that video is he's trying to say whatever is here is what goes into the function. So whether it's, and then remember he did the quarter. It's a real quarter. It's like, ooh. So we can plug in a quarter. So whatever is here goes in, right? So 3x, we go to the g function. G of x is x plus 1. Now, if you need to, you could like say, okay, g of x is equal to x plus 1. You could insert that. So wherever I see an x, and it becomes challenging because people are like, well, I already have an x. What am I going to? Just remember, whatever is here goes in for x. So whatever is here, we're inserting, in this case, 3x. So instead of x, we're going to actually write 3x plus 1. And then at that point, there's nothing else you can do. It's just 3x plus 1. Yeah.
Can you redo that just like slower?
Yeah, well, we'll just do a different one, maybe. So let's go with, I can redo this one. Let me erase this. Get all that notation out. 3x. So what is f of x? We come back up here. What is f of x? 3x. So instead of saying g of f of x, what can we ask? Instead of saying g of f of x, we just say g of 3x, because that's what f of x is. Up here, it's 3x. So we just say, okay, what's g of 3x? And that's equal to, so then we go to the g function up here, and wherever you see an x, right? Wherever you see an x, we're plugging in for here and for here. So you're plugging in 3x in for here, therefore we're plugging 3x in for there. Okay. Now we'll do another one with we can do one with, let's say, h of x, no, not h of x, let's go h of g of x, mix up our letters. So h of g of x, okay? So again, composite function, you work inside to out. So when we look at this, the inside function is g of x, right? But there's nothing to plug in. There's not like g of 1, g of 7, g of -2. It's just g of x. So we would go up and we'd look at, well, what is g of x? G of x is x plus 1, right? So instead of writing g of x, we're going to say h of x plus 1. Where did I get the x plus 1? Well, that's what g of x is. It's x plus 1. So now I have h of x plus 1, and I need to simplify that function. I'll just do it over here because we have more space. H of x is equal to x squared plus 2, right? That's what h of x is. So again, we say h of 3. Let's say it's 3. We would say 3 squared plus 2, right? Wherever you see an x, you're going to plug in a 3. So we would say 3 squared plus 2, you would get out 11, right? But in this case, we don't have 3. What do we have? X plus 1. So x plus 1 is equal to, so wherever you see an x, again, I think a lot of the challenges is understanding that this, you're like, well, I already have an x, there's an x. So maybe we would do another example, would have been better to say, like, let's say we have h of y, just pick a different variable. Wherever you see an x, what are you going to plug in? Y. So you'd have y squared plus 2, right? And then, that was the whole point of that, silly video was h of quarter. Wherever you see an x, you plug in a quarter. H of a chicken, you're plugging in a chicken. H of, so whatever you have here, you get that used to. So instead of x, what am I plugging in? X plus 1. So instead of x, what am I plugging in? X plus 1, and then squared plus 2. And then we could FOIL it out from there. And so then that would end up being, x squared plus 2x plus 2 is equal to x squared plus, 2x plus 4. And that would be your final value there. So work inside to out on those. We could do, let's do one more with a numerical value. Let's do this one. Whatever, did we already do a good G of, okay. Let's just do h of g of 3. Okay, you do h of g of 3 real quick, see what you get, and then let's make sure we're getting the same thing. So try h of g of 3, and then we'll go over it together and make sure we're getting the same thing. Again, utilizing whatever they gave you for the 3 functions. That you know, going back to what they gave you. Check with your cheat mate there, see what they got. See if they got out a number that matches your number. 7, 15, whatever it might be.
Yes.
Okay, so let's check it out. G of 3, so the first thing we do is G of 3. What do we get when we plug in G of 3? We get out 4, so you get h of 4. Right, now mental math, right, or if I'm doing G of 3, I'm just plugging in a 3 here, therefore I'm putting a 3 here, 3 plus 1 is 4. So now I'm asking what is h of 4, so we go to the h function, h of 4, right, plugging in 4 for here, 4 for here, what do you get? 16 plus 2 is 18. So the final value, your answer is 18. Okay. So hopefully that makes sense a little bit. All right, inverse functions. Inverse functions, usually one of the biggest times we talk about inverse functions actually with trigonometry, sine, cosine, and tangent. If you remember the inverse button on your calculator, that's usually where we use inverses a lot. Let's review vertical line test. What does the vertical line test tell you in mathematics? If you have remember doing the vertical line test? If something is a function, do you remember this? I mean, we have done this, right? So is this a function? You check it because a function by definition is every x matches the one y, but a y can have multiple x's. But you couldn't have, if you had a graph that looked like this, that's not a function because it doesn't pass the vertical line test. Okay, so the vertical line test tells you, is it a function or not? Okay, so is this a function? Yes. Is this a function? No, by definition. So this is a function. Now that's the vertical line test, we already know that. What we're going to add today is a horizontal line test. Okay, what a horizontal line test is it's the same concept except you do a horizontal line. Now a horizontal line test is not testing whether it's a function or not. It is actually testing whether or not it has an inverse. Now I'll explain what an inverse is. But if you have this, we say passes the vertical line test, check, it's a function. However, it doesn't pass the vertical line or the horizontal line test because this y value, whatever it is, matches the two x values. So this would be, therefore, no inverse. There's no inverse to it, which I'll explain what that is. And it is not a word or a phrase you should know, not 1, 2, 1. Now, 1 to 1 sounds maybe a little, maybe you have it, maybe you haven't, but all a 1 to 1 function is every x has one y and every y has one x. There's not a y value with two different x's. There's not an x value with two different y's. So 1 to 1 means every x has one y, every y has one x. It's 1, 2, 1. So if it doesn't pass the horizontal line test, it does not have an inverse and it's not 1 to 1. Those go hand in hand. If it does pass the horizontal line test, like let's say we have half of a parabola like this, and we look at this and we say, okay, this passes because no matter where I draw a horizontal line, it's only going to hit in one spot. This has an inverse and therefore is 1 to 1. 1, 2, 1. Okay? So has an inverse. Now, what is an inverse? The general idea of an inverse, I think the easiest way to explain it is to state that an inverse is x's and y's get flipped. So if you have a graph, so we'll do like what is an inverse? What is an inverse? Graphically, it is where the x's and y's just get flipped. So if you had let's pick something somewhat easy. Y is equal to 2x plus 3. I say somewhat easy because is that easy to graph? Hopefully, it's easy to graph. This is going to form a line, right? And then you should be able to graph this, right? Up 3, slope of 2. I won't put you on the spot because it might embarrass us. Definitely don't want that. Not today. Not on almost Valentine's Day. Everybody needs a win today. Here we go. Okay, so hopefully you would be able to graph something like this. Okay. So if you did an XYT chart for this, okay, we don't need to do an XYT chart to graph, but if we did an XYT chart, if you plugged in -2, you'd get out -1. If I get off, just let me know if I'm doing it wrong. Plug in -1, you get out 1. Plug in 0, you get out, not 0, but you get out 3. Plug in 1, you get out 5. Plug in 2, we'll just do that, you get out 7. I think I did my mental math right. Okay, that's the XYT chart for this graph. There you go. Now, I should have maybe picked a little one that's less steep, but that's fine. I just want to draw it like this. Okay, so an inverse, does this have an inverse? Sure. Does it pass the horizontal line test? No matter where you cross, where you go with the horizontal line test, it's only going to intersect in one spot. You can look at it and say every x value only has one y value, right? There's only one unique coordinate for it. So what is the inverse of this function? Well, the inverse of this function is, I'll do it in green here, we'll graph it in green. The inverse is just switching the x and y coordinates. So we actually don't even have to know what the equation is, but I'll show you how to find the equation for the inverse. But it's just switching the x and y coordinates where we say this was -2, -1, now it's -1, -2, 1, -1, 3, 0, 5, 1, and 7, 2. All you do is just switch x and y, switch x and y, switch x and y. So it's a great way when you go to graph something outside the line it's like difficult to actually find the inverse, or the inverse looks confusing. All you have to do is, what are the x, y coordinates for here? Switch them over. What are the x, y coordinates now? And this is the inverse. So we say a -1, -2, and then 1, -1, right? And then 3, 0, like that, and 5, 1, so on and so forth. So what we see is that you have this line like this, go like that, okay? So this would be the inverse of this, okay? This is why this is the inverse. Now the inverse, if they intersect, any function and its inverse, they will always intersect. I don't have the other color. I don't, that's okay, we'll just do it in dotted. They will always intersect along, if they do, they will always intersect along the y equals x line, if they intersect. Now when you go to graph them, that's the y equals x line actually isn't like part of the graph, but that's where they're reflecting over. It's just like, it's just because you're just switching your x and y coordinates. So how do I actually find the inverse, okay? Well, to find the inverse, if you are given a function, now sometimes, right, the function's written as f of x, and I write that in function notation specifically to discuss what we're going to need to do in the end for an inverse. If this is our function, okay, step 1 is put it as y equals 2x plus 3. So this is to find the inverse. To find the inverse. If it has one. To find the inverse, we say, okay, I'm going to make it y equals 2x plus 3. And then there's two different routes to go. It doesn't actually matter too much. So what we're going to do is, we are going to switch x and y, So you're just going to go x equals 2y plus 3. So you switch the x and the y, and then you solve for y. So step 1, make sure it's y equals. Step 2, switch x and y. And then step 3 would be solve for y. So we'd say x minus 3 is equal to 2y. And then a lot of people do this. It's not wrong to do this. They write it as x minus 3 over 2. That's true. A lot of times I like to put it into the slope-intercept form when I'm dealing with lines. However, either one would work, okay? This is going to work, or this. This is now your inverse. The notation for inverse notation, this is important, is f, and it looks like it's f to the -1, but we actually don't say f to the -1. We would say f inverse of x, even though there is a -1 in the exponent location. But it's a notation thing called f inverse, okay? So it doesn't flip 1 over f. It's not doing that. It's just, that's called f inverse. So if you see this on a function, you know you have graphed the, or you are looking at the inverse of a function. You know, on your calculators, remember in geometry, with trigonometry, you see sine -1 on your calculator, and we said it's not sin -1, it's sine, it's inverse sine, even though it does say sine to the -1. Okay, so there's your function. This would be your function here. This would be its inverse here. Important to distinguish the notation. So when we are going to label it, because they'll say graph and label, then you would say, you could just say, there is your f of x, there's your inverse of x, and that's your two graphs. And your two graphs and the two functions. Now, not everyone has an inverse, okay? So how do we know if it has an inverse or not? Well, you would graph it, right? And then see if it has an inverse. So if let's do an example here of, let's say you have g of x is equal to the square root of x squared, okay? So you have g of x is equal to the square root of x squared. So what we want to do is graph this and then use the horizontal line test to see if it has a function. Now this one looks a little funky, right? Because it's the square root of x squared. But, okay, so if you don't have a calculator to graph, which none of you do, right? You don't have a graphing calculator, it's just no problem. What's the easiest way to graph? Desmos, but we don't have Desmos, right? So what's the most basic way to graph without any type of calculator or computer to do because, do you know what that graph looks like just looking at it? I don't. I have a general idea, but like this one, you got a good idea, right? A line, a parabola, hopefully you got a pretty good idea, at least what it generally looks like, right? So in this case, we don't. So what's the most basic thing we can do to get a graph going? Do an x, y t-chart, right? So what's some values you want to plug in? Do you only want to plug in like 1 and 2 and then connect the dots and make a line? No, pick some negatives, pick some zeros, pick a 0. So -2, -1, 0, 1, 2. That should give us an idea. If it doesn't quite give us an idea, we could probably revisit, giving us some more points for it. All right, so if we plug in -2, we get out, what do we get out? If you plug in -2, you get out 4 there. Square root of 4 is 2. Plug in -1, -1 squared is 1, square root of 1 is 1. Plug in 0, you get out 0. Plug in 1, you get out 1. Plug in 2, you get out 2. Plug in 2, you get out 2. What do you notice on this? This is the graph. You actually don't even have to graph this to recognize does not have an inverse. How do you know this doesn't have an inverse? Because this y value of 2 occurs twice, matches to how many x values? This one and this one. So if a y value matches to 2 x values, like come back over here, if a y value matches to 2 x values, like this x value here, this x value here, match to the same y value, will it pass the horizontal line test? No. So you could graph this, if you were to graph it -2 up to like this, -1, 1, 0, 0, then it comes back down, and this actually would form that type of V graph. You know, and if you're like, oh, is it a curve or a V? I mean, you could graph it, even if you made a little bit of a curve, that's fine. Well, you actually recognize is this isn't even a function, right? So it's not one-to-one. So it's not even a function, so therefore it wouldn't have an inverse. So no inverse on this one. Let's do enough time. I think we have enough time for one more. Let's go cube root of 2x. Let me erase this over here. Okay, we have the cube root of 2x. So g of x is equal to the cube root of 2x. On this one, we can do an XYT chart. Again, here, since it's cube root, we probably, you know, you can use a calculator to find values if need be. You can also plug in some values that would create a win for you. A win being if you plugged in, well, you'd have to know your cube roots. The cube roots that you might know, or should know, what's the cube root of 64? That's equal to 4. What's the cube root of, the next one going down, if you will, would be cube root of 8 is 2. Cube root of 0, 0. Or cube root of 1 even, yeah, you know, is equal to 1. So, you know, you could say, okay, how do I get to 64? Well, I can plug in 32, and I get out, what do you do? If you plug in 32, 32 times 2 is 64, cube of 64 is 4. If I plug in a 4, you get out 8, then you get a 2. If you plug in 1/2, you get out 1. If you plug in 0, you get out 0. You gotta erase this. So I'm gonna kind of speed this up. And so then if you plug in, what do you say? Like if you plug in, we already plugged in that. I guess you can plug in negative. I'm sorry, I kind of started with the positives. So now you're going negative 1/2. Can you do the cube root of a negative? You bet. And you get out a negative. And then you plug in a negative 4, and you get a negative 8. Cube root of negative 8 is negative 2. And then so on and so forth. So what we see here graphing wise, like over, like way out here, 32 up 4, right? Something like that. And then over 4 up 2. Where are we at here? Over 4, you know, something like this. Up 2, over 1/2, up 1, 0, 0. Then negative 1/2, down 1 here. So what we actually see is this graph is going to look something like this. Now you may not fully recognize that, but that's the look of the graph. Does it pass the vertical line test? Yes. Does it pass the horizontal line test? I'll give you a pro tip. Yes. So it does. Because even though it looks like it may go horizontal, it's slowly going up, right? Just slowly going up. So does it have an inverse? Yes. Okay. So it is 1-to-1. It does have an inverse. How do we find the inverse? Step 1. Let me just do it right over here in our last little minute here. Step 1, y is equal to cube root of 2x. Step 2, switch x and y. Step 3, solve for y by cubing both sides and then divided by 2. And then that would be your inverse is equal to that right there. Okay, so that really concludes it. Tuesday, we don't have school Monday, right? So Tuesday, what is going to be due? 11/2 for sure, right? All right, I'm sorry, 10/2. And then we'll make this one due, we can make this one due Wednesday is fine. Tuesday, then Wednesday, kind of a delayed training process. So when will this one be due? Wednesday. So make sure 10-2 is ready for Tuesday, not Monday.